Hello everyone. Today we are going to look at polynomial functions of higher degrees. In here, we are going to look at the following topics. We will use transformations to sketch the graphs of polynomial functions. We will use the leading coefficient test to determine the end behavior of the graph of these polynomial functions, and then lastly, we are going to look at the zeros of the polynomial functions. So let's start with the graphs of polynomial functions. Now, we have learned how to sketch graphs of polynomial functions of degree 0, 1, and 2. So let's have a little recap of them. Polynomial functions of degree 0 is a simple constant function. For example, fx equals 3. And we all know that the graph of this polynomial function, which is a constant, is a horizontal line. So this is fx equals 3. So remember, this is my x. The vertical line is my y. Okay, now let's look at polynomial functions of degree 1. Which we call it to be a linear function. Now let's look at a very simple example, fx equals 8x minus 9. Remember, anything which is in front of x is called the slope. So what is the slope over here? M is 8. Okay, minus 9 has a very important concept. Minus 9 refers to the y coordinate of the y-intercept. So in other words, minus 9 here is, we're looking at the y-intercept. That's your b, guys. Remember that. You know, mx plus b. So minus 9 represents the y coordinate of the y-intercept. So if I want to draw this graph, first of all, looking at 8, it's a positive number. That means the line, that is the graph of this function, is a line is going up. So let's draw the graph over here. So what do you see? It's going up. And I'm just going to eyeball it, and I'm going to say where it crosses the y-axis below the x, okay, is minus 9. Because remember, the y-intercept is 0 and minus 9. So this goes here, guys. And the slope is positive. Okay, this is what is a polynomial functions of degree 1. Now, we also learned about polynomial functions of degree 2. These are quadratic functions, and we know that the graph of a quadratic function is a parabola. Just looking at this one, because the coefficient of x squared is a positive number, we know that the parabola is going to be opening upwards. Something like that. That's what we basically know. And that's the only thing. Otherwise, in order to find exactly how the graph looks like, we will have to do completing the square and stuff. And remember, you go back to your earlier videos on this chapter in section 3.1, we talked about quadratic functions in much detail. Now in this session, we're going to talk about graphs of polynomial functions of order 3 and above. Now let's start with the very simplest of all this is a polynomial function of order 3. We are going to, guys, look at cubic functions. Okay, cubic functions are polynomial functions that have degree 3. And the simplest cubic function is fx equals x cubed. Now if you remember, if I want to draw the graph looks like this. I'm just eyeballing the graph, okay? Now that's what the graph looks like. This is your x, this is your y. If you don't remember, just go ahead, write down a bunch of numbers. Easy ones too. So I would say minus 1, 0, 1. And so let's put minus 2. I think that would really make it different too. So let me write them again. Okay, so, oops. Oh, something just went a little bit. Okay, now, say minus 2, minus 1, 0, 1, and 2. So when you put minus 2, now remember it's x cubed. That means it's minus 2 cubed. It's minus 2 cubed. That means it is minus 8. When you put minus 1 cube, you get minus 1. When you put 0, 1 cube, 1, 2 cube, 8. Okay, now let's look at the domain. Domain is the values which my x can take. Now here, x can take anything. There's no restriction. So what is the domain? It's just the set of real numbers. Or if you remember in the set notation, minus infinity to infinity. Either one of them, guys, you can write. There's capital R or in the set notation form, minus infinity to infinity. Let me make it so it's R, or in the set notation, minus infinity to infinity. Now range. Range means where is my graph going? You look at the y-axis. Now clearly it is going endless downwards and endless upwards. So the range again is R, or we can write that as in the set notation, minus infinity to infinity. Now the intercept. So where is the graph intersecting the y and the x-axis? It's intersecting at the point 0 and 0. That's my origin. So the intercept for this one is 0 and 0. It is an odd function. Yes. The reason is if I change x to minus x, if you remember that. So minus x means in this original problem, change x to minus x, and then wherever you see on the right hand side, x or whatever the values x are, you replace that by minus x. So it's minus x the whole cube. What do we get? Minus x. So what do we see here? This is minus of the original function fx. What is fx? X cubed. So clearly it is an odd function. It's an increasing function. Yes. The reason is you can see the graph going up. And that's the meaning of increasing functions. Okay. As we said, we are going to be looking at creating new graphs of cubic functions. Okay. So from the previous slide, what was the cubic function looking like? Just a rough graph of it. Goes up and down. Okay. Now, remember the transformations, guys, we have done earlier. So that's what we are going to be basically applying to this graph. So this graph is given the form here. Now, when I say x cubed minus 1, so original parent function is x cubed. Now, what does that mean? This graph goes down by 1 unit. So when I want to create this graph, what am I going to do? This same graph, but I'm just going to take the graph down by 1 unit. So in other words, the graph which was crossing at 0, 0, now is going to cross at 0 and minus 1. The shape does not change, guys. Remember that. Very important. The shape does not change. It's just the translation of the graph by up or down. So here, because it's a negative number, adding to the original function, so the graph goes down by 1 unit. Okay, so in a similar fashion, when we look at hx is x cubed plus 2. So here what is happening to the graph? The original graph is now moving up by 2 units. Okay, so let's go ahead, make this graph. So the new point of y-intercept is 0 and 2. So this is the point 0 and 2. Okay, let's look at the next one. Here we are having hx to be x minus 2. Now notice the change is inside the parenthesis. That means the change is happening to the input. If you recall from your transformations, if the change is inside or having an effect on the input, that means there are horizontal movements. So minus means that we are moving the original graph to the right by 2 units. That's what it means. Okay, so let's create the graph for this one. The same graph, there won't be any change in how the shape looks like. But now instead of having 0 and 0 in the original, we are going to be having the graph moved to the right by 2 units. Okay, and okay, so this new intercepts. This one has a x-intercept and a y-intercept. What we are more concerned is with the x-intercept. That's what we need here. So it will be now new point would be 2 and 0. Now moving forward, the same graph has done what? Not only it moves horizontally by 2 units, but then there's a up movement by 4 units. So the new graph will have the point where there's a change from, it's going like this. It's going to be at the point 2 and 4. So eyeball this 2 and 4 and just simply draw the graph. So this is the graph x minus 2 cubed plus 4. The green one is for this and the blue one is for this. Okay, so it's quite a recap of the things we have done. I would like to add and do more new graphs of cubic functions. So here we are going to create new graphs of cubic functions and once again practice things we have learned earlier. That is basically transformations. Now notice, when you see x plus 2, now this gx is x plus 2. Now remember the change is in the input and if it is a positive sign, that means the graph moves to the positive sign means the graph moves horizontally to right by 2 units. Okay, so when we make that graph, so we have the graph here. So x plus 2 means here. This is where the graph would be now. And then we just remember the shape won't change, just like this. Okay, so a little, okay. So this is the graph gx. So if you want to keep in mind what is the original graph, this is how the original graph looks like. This is fx equals x cubed. So this is the point, guys, which has moved. Now the new x-intercept is minus 2 and 0. Okay, now what we have done in the next graph, our function here too, is that we have not only moved the graph to the left by 2 units, but minus 1 means we also move the graph down by 1 unit. So that means this graph now will come down by 1. So minus 2 and 0 will now become minus 2 and 1 here. Okay, so here's the new graph. So this change, when it is going to go up and down, it's now going to happen here. So this point, guys, is now going to be minus 2, minus 1. And you just, the shape remains the same. Just remember that. Okay, we're just giving a rough look to the graph. Okay, now a very important concept, minus in the front. Now recall from your transformations what we said. If you have a minus in the front to the original function, that means there's a minus multiplied to the original function. We are talking, this means vertical, or minus what I would say, not it's a vertical stretch or a shrink, but I would more look in terms of that this graph flips across the x-axis. Or it's a vertical, okay, so it's a flip across the x-axis. So minus 1 will change the values. And the best way to show is that, let's look at the values of x cubed. So I'm going to first write down the values of x cubed from the previous one, and then I will show you. So here, let me write those values. Simple values for us to work with. Remember, minus 2 was what? Minus 8. Minus 1 was minus 1. 0, 0, 1, 1. And 2 was 8. So this is x and this is x cubed. Now for minus x cubed, what's going to happen? Let's write them down. I'm going to use blue for here. So this is x and this is h of x, which is minus x cubed. So if it is minus 2, it will become positive 8. If it is minus 1, 1, 0, 0. 1 becomes minus 1, okay? And 2 becomes minus 8. So if I want to draw this graph, so what's going to happen? Instead of graph going like this, it's going to flip like this, okay? So here's the graph now. The graph goes like this. Okay, that's the graph of hx equals minus x cubed. Okay, now let's look at the last graph. It says minus x cubed plus 4. So this original graph now is going to move up by 4 units. Let me get a little bit more space for us to see. Okay, now remember, hx is minus x cubed. I'm going to add a 4. That means it moves up by 4 units. So the new graph, so remember this point is now going to be here. So this is how this new graph looks like. This is hx equals minus x cubed plus 4. Thank you, and we will continue later.